second lecture for CVSB 203. The good news, is this is the last time I'll be giving you a lecture in this course. So it's not like you're going to come every week and see me talk. I know it seems like that. So this lecture is about the scientific revolution. Let me say something first about the title. I should have changed the title. It's called The Scientific Revolution, Its Meaning and Justification. But what I really want to get across would perhaps better be served by a title like The Scientific Revolution, or Interpreting the Scientific Revolution, or What is the Scientific Revolution, or something of that nature. Because what this lecture will really be about, and what I want to focus on, is giving you kind of the right approach to looking at the scientific revolution through the text that we are reading. And let me tell you first what I think the not the optimal approach is, and then I'll tell you what the right approach is. Approach that wouldn't be optimal is that you go into this week reading the texts by Descartes and Francis Bacon with the thought that they are going to tell you what science is, and that they, to some extent, created science by writing these texts. So when Bacon lays down the foundation and methods of modern science, of the scientific revolution, that with these and through these texts, he was creating a tradition in science. That's not what was happening, and I want to make that very, very clear. Rather, what happened was something quite different. There was an immense change in the way that people thought, something we now call the scientific revolution. It was marked by a lot of things, a lot of symptoms that you will recognize, the publication of books about various topics that seem scientific, like optics and anatomy and chemistry, and new proposals, some of them that we now have discarded and seem totally crazy to us, but all kinds of new thinking that was published often, first most of it in Latin, but then in common languages like German and French and English, and a kind of explosion of interest among not just priests, but common people in technology, early technology. And then soon followed the things that we really recognize as science, like the invention of the telescope. These were actually quite late in this change. But what happened, this social change, this cultural change that happened throughout Europe preceded these writings that you're going to read. So these are not creating the tradition. They are early, and some of the very earliest attempts to give a philosophical interpretation of what we call the scientific revolution. That's why perhaps this would be better called Interpreting the Scientific Revolution. That will make sense of the fact that, as you'll see in this section, Descartes and Bacon have often completely opposed, contrary interpretations of that change. What made that change possible, what it meant, and how it should function and serve in our societies, right? So they had very different views, and that's what I'm going to focus on today. Okay, so just to give you a sense of what was going on, the text you are reading by Descartes and Bacon, you're going to read by Bacon a work, or part of a work that he planned that he never completed entirely, called The Great Instauration. Within that was a text called the New Organon, which I told you last week or the week before, that the philosophy of the medieval period was dominated by a Christian Aristotelian philosophy. And part of Aristotle's philosophy, in fact, his logic and his doctrine of method, so his teachings on how you come to discover knowledge and how to interpret knowledge and how to justify knowledge, all of that was called the Organon. Right, that traditionally. And so when Bacon is writing within his Great Instauration, which is often also translated as the Great Renewal of the Sciences, part of that is a new organon, a replacement for the old methodology of the Aristotelian tradition. So when you're reading that, you're reading texts from I believe, does anyone know when Bacon died exactly? Around, anyone? Someone want to look it up? I don't know off the top of my head, actually. Descartes died in 1650. Bacon was just a little bit earlier. So these texts are from the early 1600s, yes, that you're reading. Some as early as the late 1500s. So while that was going on, in fact, going all the way back into the early Renaissance, you had a lot of scientific, what I said is a scientific change in culture, an interest that was outside of the scholarly class or the priest class of people, that people interested just in studying certain topics. And some of the fruits of that, let me just give you some examples. This is just a smattering. I could not possibly take you through in an hour or 2 hours just the books and titles and contents of things published in this period. But just some of the things. 1543. This predates the text that you are reading, right? Vesalius is one of the most famous early modern breakthroughs in science. Is the microscopic, almost microscopic, study of the human body and human anatomy. This picture, it's quite provocative, yeah? It was intended to be because science wasn't just something for this priest class of people to talk about. Science was something that should grab the attention, should also sell books. Because now with the printing press, one of the main things that you can do is make money if you're not wealthy, and you can make money by selling books because there are lots of people out there who can buy pamphlets and books now suddenly. And so science books get created just as today. Popular science, Stephen Hawking's book is in this tradition of Vesalius because these beautiful, also quite striking, shocking depictions of the human body are both artistic, so people will want to own these, to show them at parties, to look at them. They're both artistic and scientific, right? Just think about the kind of person who would want to purchase such a text. And so this text is full of all of these different, bodies in different states of dissection, being posed in different ways. It's also large format, so it's really meant to be looked at and observed for its visual, not just its scientific content. So this is an early text. And what was new here? What was new was the desire to actually the boldness to actually show that you have dissected human bodies, right? Something that was taboo. Even when this is published, it was still taboo in most places. And to popularize it, to publicize it, to even make money off of it. Descartes, who you'll read, is also very famous, although he's not quite in the same tradition of science as Vesalius. Descartes also is famous for dissection and doing this kind of thing. In fact, there's a tale about how he had to move because his neighbors got so upset because of the stench coming from his rooms because he was dissecting various things in there. Yeah. At the same time, you've probably heard of Vesalius. You've heard of William Harvey. That's another person working around the same time, publishing on the discovery of the role of the heart as a pump, right? That's actually what it is. In fact, Descartes, again, this is something Descartes had not learned. He believed the way the heart worked was quite different, right? It was kind of a mechanical machine. But the discovery and the proof that the heart was the central organ that pumped blood around the body, this is something also a discovery of the time, William Harvey, on the motion of the heart. Galileo, you've all heard of Galileo, right? Galileo's books, what was important about them? He was condemned about, a dialogue he wrote defending the Copernican world system. But more important than that book for the fame of Galileo was, again, a book like this with pictures in it to popularize science and to popularize some things that people did not know before. Just a few years before the publication of this book, I believe it was a Dutchman, I'm not entirely sure, discovered a kind of toy you could use to look at distances, right? And Galileo got an example of this, and he redesigned it larger, and he pointed it up in the sky, and he looked at the moon, and he discovered, and he wrote in this book, The Starry Messenger, he discovered that the moon has actual geographical features on it, right? It has mountains and valleys, and it's imperfect. if you were here last week, you would recall that in the medieval system worldview, everything, the moon and above, is perfect, unchanging. So if you can find evidence of actual geological things just like on Earth, that we know that volcanoes come because they erupt and mountains come from various things, and there is all this evidence that the moon has the same kind of changing surface features that the Earth has. Suddenly you've got a great piece of, not proof, but evidence that there's something wrong with the old Aristotelian view, right? And he did the same thing in the same book. He described sunspots, spots on the sun. Again, the sun was supposed to be above the moon in that old system. So again, showing that the sun has changeable features. The sunspots come and go. He also described the moons of Jupiter. What at the time, Galileo was, he was the teacher to the children. He taught geometry to the children of the Medici family in Florence, if you've probably heard of them. And so he called these early moons, the discovery of the early moons, he called them the Medicean stars. So if you ever go out at night, you can do it here, even Beirut, with all the light pollution and real pollution, and hold your telescope up, you can generally see 4 bright dots that over different nights show up around Jupiter in different patterns. And what he did was, in this book, he shows from December 4th, December 7th, December 8th, here's the different patterns. And he deduced from these pictures that these were going around Jupiter, which shows that not everything rotates around the Earth. Right? So something else rotates around another body. Suddenly, this is not proof of the Copernican system, but it's a powerful proof to the public, to the reading public, that that Copernican theory, there might be something. At least the old theory is not as solid as people had once thought. Right? And I cannot overemphasize the similarities here between these two works. The idea of presenting pictures, just saying, look, here is the evidence, and presenting it not to, the Pope or to someone in a book that no one is going to read, but presenting it in a book that will be published and printed and sent all over. In fact, this book was the part of, later, a correspondence between Kepler and Galileo on the same topics, on related topics, right? Just skipping to another field of science, chemistry. Now this chemistry, 1661, chemistry was quite delayed. It's a bit more complicated than looking at planets and trying to deduce how they move, right? Chemistry, you cannot see what's going on. You have to deduce from various kinds of experiments. Chemistry, however, goes all the way back to alchemy and early attempts to turn gold into lead and these kinds of things. And slowly, through the application of mathematics, which is one of the major changes that took place in this early modern revolution of science, was the idea of applying mathematics in science. They could come to see that certain things, when you combust certain gases with each other, oxygen with other gases, and when you combine certain things, they combine in certain whole number proportions, and that gave the idea that there are things like molecules, that everything, that water, for instance, is made up of 2 of one thing and 1 of another thing, right, in proportions. And that started to kick off the early modern chemistry. Of course, part of that, you can already guess, is the idea of atomism, which was also popularized in a lot of books of the time, in poems. I mentioned Giordano Bruno last week. Another thing that he is very famous for is being one of the very earliest people to repopularize ancient atomism and bring that into early modern science. So atomism, which is an ancient theory, but was revived in the modern science. So Robert Boyle here, the skeptical chemist, he's just one of the famous chemists. Most of the gas laws that you all have to learn in science, and this is named after people that were working in this period. Still another area in physics, William Gilbert on the magnet. This also 1600. So Bacon actually refers to Gilbert in your reading. Gilbert was obsessed with magnets. He didn't know how they worked, and he was particularly obsessed with a problem related to magnets, which is how compasses function and why compasses function. They had them Someone had discovered, there are these natural magnets called lodestones, and maybe a little piece of it broke off at some point, and it was so small that it perhaps floated in water, and people noticed that it always floated in the same direction. And then they realized, well, magnetic objects floating, on a cork will always point in the same directions, and this can be used for navigation. Of course, this was part of what made possible all of the explorations of the New World, but we didn't know why it worked, why this happened. And Gilbert was the first person to come up with a theory about this. He did this by experimentation. He created a sphere, a magnetic sphere that he is supposed to be like a little Earth. And what he wanted to demonstrate was that actual reports of what compasses do at different points on the Earth, in the oceans, corresponded to what a tiny sliver of magnet would do in the vicinity of a certain kind of spherical magnet with poles, right? So he created a little Earth that was magnetic, arguing therefore that what made these work is that the Earth itself is a magnet and has a magnetic field that they are following. He took that very far. He thought that your soul is magnetic and all kinds of crazy things in his book. But this is typical of early modern science. There are great discoveries, and there are things that you and I would recognize as science, and then there's a lot of other stuff that they didn't know what science was, right? So they couldn't really separate them out and say, well, here are my religious thoughts and here are my scientific thoughts. They were starting to do that, but it still had very far to go because, as you see in Bacon and Descartes, no one's quite sure what science is. They disagree. And what the right methods are, they disagree. And what the limits are to scientific explanation, they disagree. So Gilbert's also interesting because, as I said, he's mentioned in Bacon's text. And although he did a lot of empirical research, right? If you look at his book, it's just all kinds of experiments, examples of experiments and the results. Francis Bacon doesn't like him very much. He calls him an empiricist, the empiricists that's a negative term for Bacon. He thinks that they're too obsessed with experimentation and too obsessed with what they sense and touch and things like this. So we'll talk about this a bit more. But William Gilbert, quite an important figure. Over here, Kepler, I'll say something about Kepler. Of course, some things we don't think about so much as that the interaction between these different fields. There were no fields of study like physics, astronomy, chemistry. They just differed insofar as different people were doing them and maybe they used different instruments. But there was no classification of the sciences like we have today. And so some of the early problems that Galileo ran into with showing other people stuff in his telescope, he realized that other people couldn't often see what he claimed to see, and he didn't know why, was because they didn't understand the way the lenses of the eye work. And Kepler wrote a book on the optical part of astronomy. This is so it's an interaction between something like what Vesalius was doing, right? These are different depictions of the possible internal structure of the eyeball, but being used specifically to try to understand how to improve telescopes. And particularly, there's this issue if you ever use a telescope that you have to adjust the eyepiece to your own eye. And it doesn't necessarily work for everyone else. This is a problem. So if you ever get an early telescope or a telescope yourself, buy one here in Beirut, and you show a friend something and they don't see it, what you see, don't be surprised. It's not a trick. It's that your telescope has to be adjusted to your eye, right? You could see how this could cause a problem with someone like Galileo at the time. He publishes a text with all these pictures, and other people get a hold of telescopes and they can't see what he's talking about, right? And no one knows why. So there is, for any kind of progress in any of these areas of science, there actually is required a kind of interaction between the sciences, right? So this is as I said, a smattering of the kinds of things that were going on prior to and throughout the period in which these texts are written by Bacon and Descartes. If you look at the figures involved here, none of the, well, I don't want to say none. I don't know anything about Vesalius too much, but for the most part, the people that are famous these are not priests, right? These are not people who, particularly in astronomy, most of the people working in astronomy made their money doing astrology on the side. Kepler did, right? Or Galileo, he's teaching geometry to some people's children to making a lot of money doing it, of course. But science is not being done within the church for the most part, right? Which would be the traditional place where science would be done. It was being done by often people who didn't know even Latin, who didn't, even necessarily read, people that you would think more like engineers. Right? They were interested in practical problems. René Descartes, who you'll read this week, he was educated by a man called Beeckman in Holland, and Beeckman was just an engineer. But he taught Descartes the methods of applying mathematics. He taught him basically two things. He taught him the power of the theory of atoms. Of course, Descartes doesn't believe in atoms, as you'll see, but he believes that everything is made up of small bodies. He just doesn't believe in atoms because atoms are the idea of something that's completely uncuttable. He thinks everything can be cut smaller, but what was impressed on him was the power of the hypothesis that things like liquids, gases, that they're composed of tiny particles, what they call corpuscles, little bodies, and that through this hypothesis, you could then construct a mathematical model that would predict and explain certain things that happen in fluid flow and so on. And so the second part of that is that he learned from Beeckman was the application of mathematics and the creation of mathematical models. But Beeckman was not a theorist. You'll see that education of Descartes it'll completely fit his view of what science is about, right? But that is not something that Descartes created. That is something that he learned from someone who we know, very little about, because he did not become famous. He was just one of the many people. These are all the famous people, but there were many, many people working and collecting. And part of the modern, you'll see, for instance, in Bacon, part of the idea of modern science is to use the power of all the practical, individuals out there, farmers, miners, and so on, to collect information and to fuel science through the collection of experiments and unusual phenomena. Okay. So that is the background. That is what Bacon and Descartes know about, want to be a part of, in fact, to a certain extent are a part of, and most importantly want to both interpret and justify, right? Of course, you first have to interpret it before you know what you're justifying. What was all that stuff, right? So in this part of my talk, I'm going to describe the two traditional ways, two often starkly opposed ways, one associated with Bacon and one associated with Descartes, of interpreting that early modern science. And I'm just going to take you point by point through what Bacon thinks on one issue and then compare that to what Descartes thinks, and you'll see the contrast could not be greater between the two. So let me say something about the little t here. I didn't make it big traditions. Again, because what I want you to think about is that there's kind of just a chaos, right? There's just all this stuff happening. And so it's not like there was a Baconian tradition with a big T that Bacon created and so on, right? Or even that existed and Bacon was part of. There are, as it were, two flavors of interpretations of science, one associated with Bacon and one to be associated with Descartes. They did not create either of them. Descartes is not the first and the other either. But it's a question of alliances and where you see science, the most important things in science happening. And you'll see very quickly what I mean by that. So Bacon, to give a proper description of Bacon's tradition, you might call it the experimental inductive tradition. This would be compared and contrasted with the Cartesian tradition, which I call the mathematical deductive tradition. The important point here is that it's not, often if you are in philosophy or in another field, you might often hear about empiricism and rationalism or something like this. And this is really not, it's a bit of too simple to understand the real contrast between the two, because they'll both have empirical elements and rational elements, right? Bacon's tradition is focused on experiments, right? And on using experiments to interpret nature, with the idea that from experiments you will gain data, right? Some kind of original evidence and general, or not general, but particular results. And then you will try through induction to reach more general rules, never going any further in your generalizations than what your experiments justify. So induction, you'll talk a lot about this. Bacon will talk about induction in his text. Induction is this process by which you go from the particular to the general, right? Actually, let me put these down because it makes it easier. So it goes from, as you see here, from experience towards principles. Principles are the basis of our arguments, right? It starts from experiences and goes to general principles that you can later use to derive things, right? So that's the path it takes from experience to principles. It goes from effects, things that we think are effects, right? Like the color change in a test tube, or the warming up of a body, or something like that. That's an effect, and it tries to understand the causes of those effects, right? It goes from the complex to the simple, right? It's often what we call a regressive method. You go from what is given to you, and you go backwards towards its sources, origins, causes, principles, and so on. And Bacon's idea, as you will see, is that, okay, everybody's been doing this forever, since they were born, since Aristotle, since before, since probably human beings popped up on the earth. Human beings were doing induction, right? They were having experiences and then coming to some kind of views as to why that happened, right? You do it as a child. You do something and you get smacked, right? You do it again, you get smacked, and then you come to a general principle, probably eventually, if you're smart. Don't do that, because that causes, or there's something, smacks happen when I do that, right? You're generalizing from the particular to the general. Bacon's point is that process of induction, which everybody did, which Descartes will do, which Aristotle did, it must be the focal point of science. What's new in the modern sciences is the care and precision that they take in carrying out that process of induction, that they never leap from the experiences to general principles quickly. In fact, as you'll see in Bacon's text, whether we get to first principles and causes is something that he puts off maybe someday. It's not really important. It's not necessary. The most important thing is care in not making an error in the move from the particular to the general. So it's based on experiments, and it's inductive. Now I will say something a little further about experiments. Another feature you'll see in the text of Bacon is that, as I said, he's criticizes people like Gilbert because he thinks that although they're doing induction, they are not doing it very well. They're doing it too quickly, right? And they are the example of people who are obsessed with the evidence of the senses itself. They don't scrutinize the evidence of the senses. Right? It's not just the evidence of the senses. We've always had that as well. Aristotle relied on his senses. The issue is the care that you must take and the principles you must follow and the illusions you must avoid in that process of generalization. And so experiments become key. You'll see, although Bacon is often referred to, even on Wikipedia or whatever, as an empiricist, he says the senses deceive us. They're one of the greatest sources of deception. The only one that's a greater source of deception for us is our minds, because our minds are untethered from nature altogether, and we just make up things. But the senses, he says, are kind of an uneven mirror. They reflect more what us, when you taste an orange, sweetness is not in the orange, it's in your tongue, right? Your senses do not tell you the chemical composition of the orange and what's causing that. So people who are too empiricistic, who focus too much on immediate sense data, they have problems. They run into errors. And that's because they don't focus on the experimental part. So Bacon often says the senses It's the experiment that really judges what is true and false. It's the tool that helps us correct the errors of the senses. We can have, it's the devising, you'll see part of this core of his method is devising all kinds of experiments specifically so that they will avoid errors that are natural to our senses, right? That's his idea. So experimental inductive. Mathematical deductive, right? Instead of focusing on particular sense data and trying to generalize from that, people within the tradition that we generally associate with Descartes, they're much more, you see them all around. You go to the physics department, it's the people who, calculate stuff on the backs of envelopes, and they work with equations and create models. They see the tool of science not so much as experimentation. Right? Experimentation maybe verifies stuff, maybe helps us out, but the real core of science is mathematical model building, right? And the idea is you create a model, so instead of starting with your sense data and being careful not to create any big theories, instead, for Descartes, you create the big theories. That's where you start, and then you look to sense data to help you determine which one of them is correct. How do you do that? Well, you take the big theory, and then you use it to deduce. You assume the theory is true as maybe a hypothesis. Descartes thinks there's other ways to see whether theories are true. And then you deduce logically. You say, what in this circumstance should happen given these general principles, this overall model, right? And you deduce. You don't do induction. You go the opposite direction. So exactly the opposite direction. And so Descartes' philosophy is all about creating what you might say, the model of the universe, by understanding the first principles, not going, so first principles first, start with first principles, highest, most general universal truths, and move from that to experience, right, by deduction. In this case, it's exactly the opposite path. You go from the causes. So you have a theory of what causes everything to act in certain ways, and then you try to explain why the color change happens, the effect, right? Why the body heats up. Because you already have a theory in place. And moves from the simple. Descartes will focus on how the basis of one of the key things in science is that you have to begin with what is most simple. You must take your thoughts and reduce them to the simplest components to examine them for errors, right? You move from the simple to the complex, and rather than going from things back to their beginnings regressively, you go progressively, right? You start from the beginnings and you deduce everything from it. So if you want to put in mind, someone of a Cartesian bent would be some physicist who wants, they're after that theory of everything, right? You can deduce everything from it. Now, within these traditions, as I said, although Bacon is the opposite of Gilbert. Today, when we think about the Baconian tradition, or the tradition that Bacon was involved in, we associate Bacon with people just like Gilbert, Vesalius, Boyle, right? People who are interested, remember Vesalius there with the bodies, and Boyle in chemistry. All of these are based first and foremost on experimentation and on laboratory experience and trying to come up with just simple hypotheses about what's going on. On the other hand, we associate Descartes with Copernicus, who you read, right? Copernicus is proposing was his book full of empirical evidence for his theory, first of all? No, he has a major revolutionary theory that is built on almost no evidence whatsoever, right? And he gives you, the reasons he gives you in the text that you read, I hope you noticed, the reasons that he gives you to hold his theory have almost nothing to do with empirical evidence, right? They're about how it's a more beautiful, a less monstrous universe, how the sun would be better placed in the center so that it can illuminate everything equally, so on. Aesthetic, what we call aesthetic criterion, which is often what happens when you're building a theory, right? One of the things that impressed Einstein that his theory was correct was that it was so beautiful when he came up with it. It's an aesthetic criteria because nature, the assumption is nature is simple, and so the system of the world should be simple. So Kepler, again, this is Kepler is famous for having moved from circles to ellipses, but Kepler was this kind of mathematically minded astronomer. He did use empirical data, though. Just as I said, these are not simple oppositions, but this is a more general, crude division. Galileo, too, some people would put him on this. I put him on the side of Descartes because in his published writings, Descartes actually built a lot of his theory of method on reading text by Galileo. Right? But within Galileo, there's a certain, what we'd call a mathematical deductive bent, but often he is also held up as someone in this tradition, because remember, he observed the moon and so on. But I tend to put him over here where I could put him on both sides probably. Leibniz, someone you may never hear about again, but he's one of the creators of calculus and in early modern dynamics and physics around the time of Newton. Newton you would put in this, generally in this side. Von Schirnhausen, also another person of the same period, working as Descartes, interested in method and in system building. Now, understandably, these two traditions see the past because they see science as something different. Right? They look back on all the stuff that has happened and is happening, and they see it as the essence of it is completely different. Of course, they want to oppose. They say, well, our science works, for instance, here because we do experiments and we do induction. Our science works because we have the correct universal mathematical theories. And so when they look at the past and the failure, what they see as the failure of medieval science, they project something different, right? It failed for a different reason because ours succeeds for a different reason. So, of course, they all look back to Aristotle, who was the main scientific figure in the medieval period. And in the Baconian tradition, you can kind of detect whether someone's in the Baconian tradition because they will talk about Aristotle as being far too speculative and theoretical, right? He's too much like this tradition. That's why he failed. If you read Stephen Hawking's A Brief History of Time, he has an introduction there, and he talks about Aristotle, and his view of Aristotle is this, right, that Aristotle was too speculative, too theoretical, he was not experimental enough. Flew to first principles instead of that slow process of induction, right? On the other side, if you read the Cartesians, if you read Galileo, for instance, that's one of the reasons I put him over here. When he talks about the Aristotelians and to the Aristotelians, he says they're too reliant on their senses. They're too much empiricists. This is the problem with them. He has a good example there because he's thinking in the context of early modern astronomy. And what was the big thing that Copernicus was arguing for? Anyone? What was Copernicus arguing for? Huh? Okay, heliocentrism, which implies, actually his key idea is the motion of the Earth, right? He says that's the key foundation of his system. It's not really that the sun's in the center, that's true, but the more importantly, it's that the changes, all those epicycles and funny stuff business going on in the old system, all that was caused and can be removed by the hypothesis that the Earth moves, right? But the Earth moving, well, do you feel the Earth moving? How fast are you moving relative to the sun? It's over 1,000 miles an hour. How fast are you moving relative to the center of our local system? Tens of thousands, hundreds of thousands of miles an hour. Do you feel it? You know, you're also not just moving around the sun, but you're also spinning on a ball at thousands of miles an hour. Do you feel it? No. If anyone told you that, and you had never been told just to believe whatever you hear in science, you would think they were crazy. You would come up with, your mind would just rebel from the idea. Like I get on in the playground, you'd say, look, I get on the playground, I get on one of those spinning things, and I fly right off. Why am I not flying off the Earth? Why aren't the trees flying off? How does it all hold together? It's an incredibly difficult thing to accept that we are moving at such speeds and in many different ways. 3 different ways, according to Copernicus. Well, so the Aristotelians, when they talk to Galileo, and this is in his dialogues about the 2 chief world systems, the Aristotelians are represented there as saying, look, Aristotle laid down as the foundation of science, the number one thing you cannot do is go against the senses. This is actually in the tradition. And the senses say we're not moving, so sorry, Copernicus, you're done, right? And so they would bring objections like, well, if we were moving, then how do the birds keep up with the Earth, right? Because it's moving so fast, how do they keep up? Things like this. And so it took a lot of theory. It took a lot of theory about momentum and all kinds of physics that didn't exist yet to be able to make sense of why our senses tell us we're not moving when in fact we are. So for someone like Galileo working in this tradition, the people he's talking to, the Aristotelians, the main opponent the main opposition that they put forward sounds like empiricism, right? Interestingly, Bacon also doesn't accept Copernicus's theory for interesting reasons, right? So he's also not a Copernican, although he is an early modern scientist. So simply Bacon and the Baconian tradition is generally not as interested in astronomy and in system building of this kind at this period, right? So they see there's two different Aristotles. There's the Aristotle that is the Platonic theorist, and there's the Aristotle that is the crude person who's stupid and believes their senses. You'll meet both Aristotles in your texts at different points. Obviously, the Baconian tradition, they distrust the senses, but the unaided intellect at most of all. But in the Cartesian tradition, you'll see this in Descartes' text itself. The one thing you can really trust is your intellect, right? It's the intellect will be the clear, what he calls clear and distinct representation of a concept, is the one criteria, absolute foundation and criteria of truth. So unlike Bacon, the unaided intellect is the most dangerous thing, right? It's what leads us astray. For Descartes, it's the one perfect part of our nature, right? Or nearly perfect. The only thing that's imperfect about it is that our intellect doesn't represent everything, right? So the intellect is the source of truth. Here it's a source of error. Here it's a source of truth, right? Both distrust the senses, right? But in the Baconian tradition, the idea is, well, the intellect is furthest from the truth. So even though we distrust the senses, we have to use the senses. That's why experiments are important, to correct the senses. There's no other path towards truth. Truth comes through the senses. Just, it's not judged by the senses alone. But for the Cartesian tradition, there will be some kind of purely intellectual, internal to your conscience, criteria for truth and falsehood that will be applied. It's not through the senses, and they will evaluate the senses. And so in Descartes, you'll get a real emphasis that the senses are always in error, right? Nearly always in error. So I said a lot of this, so I'll go quickly. Obviously, in the Baconian tradition, you see a lot of emphasis on the design of experiments and the comparison and sifting of results. You also see a lot of emphasis on technology, on the practical results. They're not interested in the theories, they're interested in, as we'll see later, if I get there, they're interested in what Bacon calls the fruits, the products, the innovations, the discoveries, the benefits, right? The Baconian tradition generally is interested in technology and in results because they're interested in changing and improving society on a social level. That is their main concern in science. As we'll see later, if I get to the quote, Bacon says, to restore man to his place of power that God originally gave him over nature. In the Cartesian tradition, there will be, you'll see, a lot of focus on the analysis of pure concepts, whatever those are. Right? It's very metaphysical, philosophical, theory building and techniques. Baconian tradition, little or no use of mathematics. Bacon will say mathematics is useful, but when you look at what he says about mathematics, he means like counting stuff, right? That's what he means by the use of mathematics. He doesn't mean mathematics as a kind of a hypothesis about the motion of the earth and how it could be possible that we don't feel it because of inertia and gravity and so on. Not mathematical theories that fundamentally alter your interpretation of nature, but rather mathematics to count up, to collect, to do empirical, like you would in statistics, right? So this is the use of mathematics for Bacon would be like you find in a statistics course versus the use of mathematics you have in, say, electromagnetism or something, where you have these pervading theories of nature that are mathematical. Of course, for Descartes, the main tool will be mathematics. In particular, for him, geometry, but later it would be calculus and so on. Again, here, Copernicus, not very interested in the astronomical tradition, said Bacon rejected the Copernican theory. Gilbert, again, one of these odd guys, he did accept the Copernican theory. Maybe this is another reason that Bacon didn't like him very much. of course, here, Descartes was working and seeing himself primarily in terms of the astronomical tradition, although he didn't do much in astronomy, really much of anything. But when he published, for instance, his first philosophical writings, he did so as a response to the condemnation of Galileo. So he's thinking in terms of justifying the Copernican Galilean theories, and we'll see that. So this is absolutely central to not only his view of science, but his view of what philosophy should do to try to justify science and defend science. Interestingly, in the Baconian tradition, you'll notice there's really the relationship for us between religion and science is enormous, right? This is something you can't get away from today, debates and people on both sides saying crazy stuff. But for Bacon, the relationship between religion and science is not an important one. He sees science as more or less, well, it's important, but it's not a contentious one. He sees religion and science as more or less getting along happily. And so he never had any worry about being condemned. He had more worries about stealing money, which he did, apparently, and getting in trouble for things like that. But he had no problems with the results. And you can kind of see why. If you're in this kind of inductive tradition, you're not making big theories. You're not making challenging reversals of historically held Aristotelian theories of nature. You're not really contending with Aristotle directly, right? Or with the church's theories. You're doing experiments. You're sifting your data. Your point is that I'm not going to make any bold claims. There's nothing to fear for religion from the Baconian tradition when Bacon is working in it. Of course, you have to think forward. Someone like Darwin is definitely in this tradition, right? And so later, this tradition does have enormous consequences for the relationship between science and religion, right? But that required Darwin to move from empirical data to an enormously broad theory about human beings and their origins, right? Descartes, his philosophy is created in that opposition between the church and the early modern science, right? He's aware of Bruno's being burned in 1600. He's aware he was not a philosopher. He was just working in early modern science, and he was about to publish his early theories about the Earth and his early theory of method, scientific method, when Galileo was condemned in 1632, and he wrote to friends saying he would now not publish his works until he had made a thorough preparation. And then when he first published his Meditations, which was a precursor to the work you're reading, which is the Principles of Philosophy, he published that anonymously, right? So he was doing this, and you can see from his letters that he wanted to, he was strategic. He wanted to keep secret that his philosophy, this is why a lot of you, if you take Descartes in philosophy class, you'll never even talk about modern science at all, because Descartes did an extremely good job of making it seem like he wasn't interested in science primarily, but rather in things like the immortality of the soul, proving the existence of God. But there is a deep strategic plan that he has to revise the old theories, the old Aristotelian theories of the world as a whole, the source of truth, prove God's existence, prove immortality, show that his theories lead to the traditional truths of the Christian religion, and then guess what? His science follows as a necessary consequence, not the old science. So there is quite a bit of strategy involved in the way that Descartes. So his whole thinking, you have to keep it in this context of Galileo and others. Okay. What can I say here? I would like you in the slides, these are available to you here so you can read them. These are just some quotes, actually, just filling out a little bit of what I said about the experimental inductive method to show you that I'm not making this up, right? Quotes from the actual text. But then I have these main questions, and I'd like to propose these as you're reading this week to think about. I give you answers here, but search for your own answers as well. 3 main questions that faced these thinkers and should face you while reading. First of all, Bacon and Descartes are both confronted with a question of what the essence of the modern approach to science is. What makes it work? Why did, as a consequence, the earlier methods that people have been following for thousands and even 100,000s of years to reach truth were not working? Why not? This is in part a defense of the new science, right? But the question is, what makes science science and makes it different from anything other kind of thinking? Secondly, what is the test of truth in science? How do you know in science, what criteria do you use to say this theory or this result is in error and is wrong and this one is true? What criteria when the church says, the Bible says that during this period of a battle, the sun stopped its movement, right? And then they inferred from that the sun must be moving, according to the Bible. By what criteria can you say that that is not a good way of determining the truth? This is something Galileo and Descartes are faced with, right? Why is there what's going on in the biblical text, and why is that not a method for finding truth, whereas looking through some cardboard contraption with glass in it and whatnot is a good way, right? Why are those although mundane things, so immensely different in their kinds with respect to truth, at least scientific truth? And finally, what status, this is a big question, what status should science have, and what status should the institutions of science have with respect to existing doctrines and social structures? Namely, how should they relate to church and state? You'll see they have very different views on this. They both see science as essential to a state and in relationship to the church, but Bacon's work, as you'll see, places the science within the realm of things that should be funded by kings and should be a central pillar of states, whereas Descartes does not. But why and what's the reason for all of that? So thank you.